Hey everybody, this is Larry. This is Leetcode Weekly Contest 187. Yeah, there's about 30 seconds left, so hit the like button, hit the subscribe button while you hang out. Uh, what do you think about this contest? Did you do well? What did you have trouble with? What did you like? Yeah, let me know how you feel, and obviously also wish me luck. Gotta calm down. I think that's what I have to do, and just slow down a little bit to make sure I don't make stupid mistakes. I keep on making stupid mistakes and that's something I need to be slightly better at. But yeah, okay, 7 seconds. Let's go. Ooh, let's start. And here we go. Yeah, open up the forms. Destination city. Okay, destination city. So basically for this problem, you're given just a lot of paths and from point A to point B. Um, and what I tried to do here was just making sure that I read stuff correctly as I'm solving this. But the idea is just that keep track of all the cities, that's one, and then just count which, or just take a look to see which city does not have an outgoing path. And that's pretty much all I do here. And I just wanted to make sure that I read the conditions, like what happens if there are multiple outgoing cities with zero. And it doesn't seem to be the case, so that was good. And that's pretty much what I did. And I used default dictionary so that I don't have to do crazy math. I don't have to do like if statements. And I do plus you go to zero so that I put the key in there. So that's what I was doing with the plus you go zero, even though it looks a little bit weird. Um, okay, yeah. And now we just check for each city to see whether the count is zero. Otherwise, I don't know. I guess by they all have to have a thing. Otherwise, it would have failed. So um, yeah. Okay. Cool. Cool. Check if all ones are at least length k places away. Given an array numbers of 0 and 1s and an integer k, return true if all ones are at least k places away. So this one I figured out pretty quickly. I thought of two ways of doing it. One is just keeping track of like windows of k, like a rolling window of k length away. But I always have struggled a little bit of rolling windows and making sure off by ones and stuff like this. So what I did was I actually just converted it into, and I saw that n is equal to 100,000. So I just converted to an array of the index numbers that only contain the numbers 1. And then for each of that, look at two adjacent elements. And if the delta is less than or equal to k, then that's not true. I think I had an off by 1 initially, so you'll see me do that. But that's pretty much it. I really did know this one immediately, or figured out how to do it immediately, which was good. I was really fast on the first two, um, but I slowed down the other ones. So I was like, oh, true, why? Oh, off by 1. Because I thought two apart, two apart is like a little bit of an English thing. So like in terms of like interpretation. So I was like, oh, so that's like 1, 2, like two, like perfectly two apart, or two in no, it's very weird, right? So you can have interpret both either way. So after I fixed that, that's why I feel a little skeptical, because for these ones with you only get true false values, you almost have a 50% chance of getting right kind of thing, right? So yeah, okay. Longest continuous subarray with absolute diff less than or equal to limit. Um, so yeah, so for this one, I knew how to do it almost immediately. I was just trying to figure out if there's another uh, more easy to implement way to do it. I guess mono cubes are not that hard, but I was just thinking about it because and this is why you practice the things that you're a little bit rusty or just not as necessarily good at. For me, um, algorithm it was for like I know all I need to know for mono Q or max Q or whatever in terms of algorithm, but my implementation is still a little rusty. So I was a little bit just not confident about implementing mono Q, especially on the contest. And I know that this is easy for them. So when I saw this, I know that like a little bit on a meta thinking level, I was like, okay, all the top programmers are going to get it in like probably 3 to 5 minutes, to be frank. And that's where I try. I strive to be. I don't know if I'm there yet, but um, so here I knew that if I had an off by one or something silly, it's going to cost me 5 minutes, which is the entire cost of the problem, right? So what I'm doing now, and you can't really see me, is I was looking through my solution archive just to kind of find. I thought I implemented this like 2, 3 contests ago, so I was like trying to find that solution, so that I could be like, um, okay, um, so that I could just have a reference so that I could type it out, because I was like, okay, if I get a wrong answer, like I said, it's going to cost me 5 minutes. So let me just make sure that I got a reference solution that is correct. Um, but uh, but yeah, so that's what I'm kind of doing now. So you see me like not doing anything. I was also thinking of, so there is another thing that I was thinking of doing, which is I was thinking of using priority queues at this point. And you can get away with it with priority queues because it's n log n or n log, yeah, roughly n log n. I thought there was a k, but actually in this case it would be n log n. Um, in the worst case, and I was like, okay, n log n, maybe that's okay. Um, but I was like, part of that was I was striving to learn something new, and trying to be a little bit better for next time. I mean, because the reason why I'm a little bit rusty now, to be frank, is that I keep on saying I will do better next time. So you could say that at this point I'm I'm investing in my future into getting better at mono queues. Maybe that's how I would think about it. Um, because I could probably if I really was optimizing for just pure contest time, I would have done a priority queue. Like if my life depended on it, the time that I spent on this one. But overall, this is just otherwise a little bit just template sliding window for me a little bit. I like to use while loops so that I could, because I know that you could use with for loop for this particular one, but I like to use a while loop because sometimes I like to move right more than once or left more than once. In this case, I always only move right more than once. Only move left more than once, but that's just me. You could do, experiment with how you feel about things and what your weak points are, and yeah. Um, Mine are off by one, but that's easy to test and check. Um, but yeah, at this point, I was just thinking like, oh, should I? Like, I was gonna just write it out hard, and I was like, oh, should I just write a class for this? Like, do I have time to write a class for this? Uh, I'm just going mono because I was lazy to type it out. I remember I saw this from Alex, big fan. Check out his Discord channel as well while you're at the chance. I always hang out there just to kind of give a plug. And I always have a Discord channel, so hang out there if you have a chance if you're watching this. But I did get this idea from Alex, so that's kind of what I was leading to. But I was like, this is like heavy and there's like a lot of work. So should I just like, um, yeah? And then you see me like spend time here as well, being like, should I just do this? And I ended up spending about 9 minutes on this farm. So like, and a lot of that was investing in stuff like this. Um, but yeah, that was just like, just do it. Okay, what does it mean? All right, let's get the number first. I like to put in a variable so that I don't have to keep on nums that sub-right, because also sometimes you just keep on misclicking on stuff, or like having typos. And this is just a little bit shorter, and it's an ADS. Um, and then now I'm trying to think a little bit of, yeah. And this is just, right now, it is basic monoq code. And if you're unfamiliar with how monoq works, and for my variant, it is the big queue or the max queue. And there's a min queue, obviously, for the smallest. But the idea is that you keep a queue of numbers that will allow you to figure out the max and the min, or well, each queue allows you to figure out one element, one thing about it. In this case, is the max, and there's another queue for the min, and then that's essentially what I did. Um, and yeah, I'm a little bit rusty about it at this point, but I mean, I'm still okay. And I'm a little bit slower than I am on the typing side because I just wanted to make sure I was right and not rush this. because again, I'm not familiar with it, and that's what practice would get you. And I haven't practiced MonoQ at all, like in my life slash career, because fun story while we're watching Larry slowly type out the MonoQ code is that this used to be like a cute little programming trick a long time ago, and now it got like popular and only like the last I say recently, but like probably the last decade, and now like you see articles and stuff like this on it, and but like for me, I just never practiced when I was learning about these things. It was just a neat little trick that comes up once in a while, but now it feels like, for whatever reason, the meta of competitive programming, if you will, it's a little bit, yeah, to have more of these problems more and more. Um, but yeah, also, I think one thing I need to do though, while I'm thinking about this, is that yeah, and now I'm just writing the code for popping off. Like if the max and the min is bigger than the limit, then we pop off the queue. And I do have an index of out of bounds here because I didn't insert an element. Um, but yeah, I need to practice doing this in C++ as well at some point, so that I could do better in other contests as well, perhaps. Um, But yeah, and I also forgot to increment left. I just noticed. That's the one thing with while loop for me, is that I always forget to do that. Yeah, and the answers are right except for off by 1, which I noticed. So I was like, oh, right minus left. Oh yeah, you have to do inclusive. So that doesn't make sense off by 1, because if you have an off by 1 and it doesn't make sense, then like you still should check it. Otherwise, you're going to pay for it in 5 minutes. Wrong answers. But yeah, and I just wanted to check out like how to get but yeah, I was just trying to find out an answer for which the answer is 0, and I thought about it a little bit, and I couldn't come up with one. So, and it makes sense because at least your element is going to have one element. So yeah, that's Q2. Q4, find the k-smallest sum of a matrix with sorted rows. Um, um, Yeah, so this one, I struck. So right now I'm still reading the problem, my mind, I refreshed to see how many posts I made. I was like, wow, okay. But in my mind, I was just like, okay. Um, I think one thing I should have done a little bit is look at the constraint first, and I do it now. But I was like, okay, what are my tools, right? So I was thinking of dynamic programming for a little bit of like similar to the last contest of enumeration, but I was like, okay, no, that doesn't make sense. Or like I couldn't get the math to work. I did a lot of calculations of like 5,000 times 40 times 5,000 or some permutation to kind of figure out different types of possibilities. But at the end of the day, like I went through a lot of those cases and I just could not get it. Because so the one constraint that I did miss was that the k is less than or equal to 200. Uh, um, yeah, so I missed it. I told it like I know that's in my face, and I've looked at it a few times, but for some reason I just kind of like it didn't take in my mind the k is less than or equal to 200. So right now I'm just trying to figure out different ways of brute forcing in a way, but using maybe dynamic programming as a crutch to kind of fix that. One strategy that I'm going to fast forward a little bit or like skip ahead, and click on the links below to kind of skip ahead with me if you like. Um, but the one strategy that I was thinking of at this point was kind of the only thing that I thought maybe had a chance was some sort of binary search with okay, given a number, say example 4, say 12, can we count the number of sequences less than 12, and can we do that with dynamic programming maybe? But I still couldn't come up with that recurrence, so I end up spending a long time. Uh, click on the link below. I mean, I'm going to skip ahead because I literally just thought about all these different dynamic programming things for like a good 20 minutes until I was like, oh, k is equal to 200. You are, Larry, you're a little bit, not sharp right now. I just woke up. That's my excuse, and I'm sticking to it. but uh, but yeah, once I saw that, I was like, oh, a lot more things become feasible. So skip ahead, and I will join you there. don't know this one. Oh, this is 200, so I missed that part. Poop. Yeah, so at this point, I finally read the cave correctly. I remember this being longer than it was, so I definitely, looking back, had issues with the implementation, but I was just thinking about. I mean, so at this point, I knew that I wanted to do priority queue, almost like yeah, just one at a time. Get the put the next possible smallest number in the queue because all the inputs are sorted and so forth. And that was kind of a hint. And I just kind of start writing out the template now that I'm like trying to think a little bit of it. I still worry a little bit about the the issues getting too big. Um, so that's kind of what I do here. Yeah. So I started by I think right now you could see kind of some rustiness because I was just not sure how to write this code in a clean way. Um, but I am at this point. I knew that I wanted to do priority queue, and I think at the time, yeah. Now I'm just slowly writing the queue. At the time, I was just thinking about like what is the worst case for this, right? The scenario, even with k is equal to 200, and I couldn't really. You could see me deep in thought, Larry, thinking about like all these things. Well, if you want to think about it, there's like I'm talking to my best friend to that corner, or maybe, yeah, to get the answer. No, I'm just kidding. Don't report me, please. But now Larry's deep in the other Larry's deep in thought, trying to think about all the possibilities for this one. But yeah, I still end up taking 14 minutes to implement this, so this is a little bit slow for me. Uh, for a couple of weeks, because I was just very skeptical the entire way um, about the timing, to be honest. Um, like, I think now, looking back, I am able to convince myself that and I'll explain that once we get there a little bit closer. Um, but at the time, I was just not sure, and I was rushing, not rushing, but I was like feeling a little pressure to kind of wanting to do this very quickly. Um, but yeah, I'm still. You could kind of see me still trying to figure out how to really implement this. It's a little bit rusty. Usually, when I do priority queues, I do it with a fixed length of things. So I haven't practiced this variation in a long time. And I'm just trying to also. I don't know. I'm just a little bit rusty with the priority queues. I think that's. I mean, it is what it is. Uh, yeah. Now I'm just. So the idea is pretty simple. It's just that it's almost like okay. So now you're given m or n, I forget, but the number of columns, or sorry, a number of rows of arrays, and then you just take the first element because they're all sorted, and that's your smallest element. And then for next, just spread out to get, put, okay, what do we move the first index by one? What do we move the second row's index by one? And so forth, and then try to do all that. And here I'm probably just stalling, to be honest. I don't know why I'm doing this, where like it doesn't really matter. And just to get some compilation error, because I also, one thing is that I wasn't sure that line 7 was correct syntax, so that's why I was checking for it. But I was didn't really seem like it was necessary per se, the way that I'm doing it the way right now. But yeah, now I'm going for each index. Um, I don't know why I'm so. It's a little painful watching back, but that what's good about watching back is you kind of figure out where you're spending your time on, and there's no perception, there's no it's absolute honesty where you're spending your time on, and it allows you to kind of figure out how to improve better. I think I don't know, like I've done priority queues many times, so that's not the issue. It's more that I was just not confident about this solution the entire way. I think that was my major thing for this. Um, but but yeah. And when I'm a little bit confused, I write very verbose variable names instead of one letter variable names, as you can see me do here. And you could calculate it. You could actually just do a sum. This is not a big deal, but for performance, or I didn't even try to do it for performance. I just kind of do it for. I was also try. See, this is all messy in how because I was still like trying to roll around the idea in my head. I think it's part of this so part of what I was not confident about and trying to test is that like, can you put arrays in priority queue in Python? And I wasn't sure because, for example, lists or arrays or lists are not hashable, but I didn't know. I wasn't sure whether it is priority queueable. So that's kind of essentially what I'm doing here. Uh, but yeah, and now I'm just trying to figure out because for some reason I thought maybe it's possible that each array or yeah, each list could have multiple or just the variable lengths. Uh, but it actually turned out that all the matrix or all the rows have the same length. So I just like, okay, I could just do it that way. But yeah, very slow. Uh, really, I think looking back, I definitely spent time on things that like I could have been faster on this, considering that I knew the answer. But my implementation was a little slow today for this problem. Um, and a little bit rusty. You see me do one other thing that I just forgot about because I was careless or just not. I don't know why. I don't know. Sometimes you have good days, sometimes you have bad days, I suppose. And if one of my bad days, I still finish top 100, that's pretty good. Or even a little bit out of top 100, wherever I end up. Um, but yeah, but for this one, so I couldn't prove this at the time because I didn't want to spend time proving it. And even in the explanation, I don't think I proved it. But actually, fun fact is that I record this commentary after I record the explanation. So sometimes I do have a little bit more time thinking about it. So for this one, actually, um, it's good enough to it's good enough to only keep track of 200. Why did I spend 7 minutes more after this? Because I'm mostly done. But that's a little sad actually. Because if I finished now, um, I would have been still top 50, roughly. So I spent 10 minutes misreading, but I guess I was just really slow. Uh, oh, also I was doing something with. You'll see this next. Is I was doing something with the way that I wasn't sure was performant. Like I was saying, there's a lot of stuff that I was doing with this problem that I just had doubts on with respect to performance. But yeah, but you can actually use the pigeonhole principle because you're only ever gonna need the 200 smallest number. You can actually keep your Q less than 200. I choose 40,000 here because I didn't want to spend time proving, and 40,000 was just 200 square. So I was like, maybe each of those have like some weirdness or something like that. That gets me to because I wasn't. Um, Yeah, I don't know. I don't know what the actually. I don't know now that I think about. I don't know if I could prove that as well. But because you may maybe have a path that goes in a very close way. But yeah, now I'm just running into because I renamed a few things and now I'm just doing silly things. And also, heap push requires the queue element. I forgot about that. Uh, this goes on for another 5 minutes, which like is how long most people would sell a lot of stuff. Um, yeah, and I was off by one. Um, Also, to be honest, some of that was I wasn't sure what it was a K index or um, what you might call it. Uh, oh, sorry, zero index or one index. So I was like, huh? Because I didn't want to break out the loop. So I just want to print it out. Everything looks mostly okay. So like it was documenting in a way. So I was like, okay, maybe I was just off by one. But yeah, this process was a little bit slow. I should have recognized that this was off by one way much earlier, and I was able to would have been able to handle it much quicker. Um, but I don't know. I think I was just a little bit maybe tired as well, and that's like a because I was struggling on the hard problem a little bit. And something that doesn't get emphasized enough is that like the longer the contest goes, it does become an endurance contest, and especially for the harder contests. So you have to really, stay healthy, get sleep, and pace yourself. And and yeah, you could, he is tired. Um, yeah, now I'm just trying to think about like all the cases and whether it gets more crazy. I don't know why I clicked there. No, that's here. But oh yeah, and here this is a way amateur mistake of just not keeping track of states. I was like, huh, this is not actually, yeah, I forgot about this. This is not even off by one. It's just like me being silly. Um, and now I remember this part, which is that I was like, well, I knew this. To be frank, I knew that this was not one. So what I'm doing right now is googling whether or how to hash a list. I know how to hash a list, but I was trying to figure out if there's uh, a efficient way to hash a list because if we're going to do a lot of these and queuings, I wanted to make sure that it runs in time. Because again, um, even though normally I would just like if there was a smaller constraints, I may hash it in a dumb way, and I did end up hashing it in a dumb way, as you'll see. But because I was really mindful about the performance, at least for now, that I was just a little bit preemptively, maybe a premature optimization, but it's hard to tell with these problems with the search space that could grow so exponentially that like and you don't know how close you are to the end sometimes, or like in terms of the time limit until you go through it. Uh, so yeah, But yeah, as you see, I hashed the dumb way. I was just trying to think whether uh, if there's a smarter way to do it. But I was like, okay, just do it first. My focus was just doing first, and then we worry about the performance if we get to it. And with that in mind, I am going to test the worst case performance. So yeah, and obviously this isn't even good, but that's okay. And yeah, I got the right answer, but I'm not confident about this because, well, I mean, I'm confident about the code relatively, and I'm just like, so I don't do it twice. Um, and also, autocomplete removed my close parentheses. That cost me like another 5 seconds. You laugh about this 5 second that I'm complaining about, but if I had 5 seconds faster, I would have been one or two rank higher. Uh, so yeah. So in this anyway, I knew that this was good, but now I actually have used like C or something. I need to write. I need to maybe invest some time in a test case generator. But yeah, I was just looking at the worst cases and just taking, and you see me literally typing from 1 to 40. So this took some bit of time. Um, but yeah, and then you also see me try to test the 40 case, and M is equal to 40 case. Um, and that's pretty much the entire problem. I mean, I feel a little sad that I just misread for a while, but looking back, watching the live commentary, I did spend a good amount of time like just coding this, so there's no reason about it. But yeah, and you just see me try to do the N is equal to 40Ks. But yeah, thanks for watching the commentary. Stay tuned. Larry will explain the problems a little bit more in depth for each of them. And thanks for watching. Hit the like button, hit the subscribe button, and I will see you later. Silly. Didn't yeah, hmm, I just missed the K 0 to 200 part. That wasn't that bad if I had gotten that part, but let's see where I am. Top 100, but probably a little bit later when the Chinese server comes in. Uh, ugh, I thought it was harder. I thought Q4 was going to be really hard. And then the thing that got me was that when I refreshed the rankings, uh, like 20 people have solved it. So I was like, ah, there must be a dumber thing. It took me a while to write it out because I was not sure about complexity and stuff like that because it is a little brute forcey. But I just missed the K 0 to 200 for a long time. Um, hmm. So I'm not going to be in the top 100, but no, no. I have to. I mean, I'll have to look back at the tapes to kind of see, just to see how long I took on that one, because I spent a long time thinking about it, um, and yeah, most of that time was because I missed the K 0 to 200 or less. Yeah, if I knew K was 200, then I would have tried what I did pretty quickly. I don't know how I would have done per se. And I was also, obviously, you saw me spend a little bit of time near the end to be really careful because I really wasn't sure about the worst case situation and stuff like this. But yeah, so I probably spent like an extra 2 minutes, which, wow, like just testing the last one. And that 2 minutes would have been like 80th to 90th. I mean, it's okay. Um, not, I mean, yeah. Could I have done better? Should I have done better? So I just didn't. I mean, I missed a really critical part of the reading, so that was a reading comprehension fail for me. Because I did the first two and really well. I was going to say the first two real quick, but people got faster because I guess it was quick for everybody. The third one, I knew how to do it immediately, but okay, let's go through the code, and then we'll go through it together. Um, Sorry, let me. I mean, as I know that you may be watching this on YouTube, but I'm taping this live, and I'm just trying to recollect myself. That was a 40-minute solve, if you will. But uh, so that's why I'm like pacing myself a little bit and just catching my breath. Thanks for staying with me if you're here. If you're watching this portion, leave a comment. Thanks for your support, and we'll give you mad props. But let's go over the problem now. 5400 destination city. You're given array paths where paths is you go to city A, city B means there's an existing direct path from city A to city B. Yeah, so here I just did a very brute forcey thing of well, keep track of all the A's and all the B's that you're given, and then at the end just go through all of them and then see which one has each one has no outgoing path, which is literally what it's asking. So this is O of n, pretty straightforward otherwise. O of n, O of 1, depending for each of the hash table lookups. So yeah, so that's problem one. Problem two, check if all ones are at least length k places away. So yeah, so I did this pretty quickly as well. I thought of doing some rolling window type thing, but I was like, it's maybe I'm going to be off by ones. Though I did, if you watch the tape, I had an off by one anyway. But basically, essentially what I did was for every number in nums, I just keep track of the index if it's in number, if the number is one. And then I just look at all adjacent copies or adjacent numbers to see if they're less than or equal to k. If that's the case, then it's false. I had an off by one because yeah, because it has to be equal to instead of less than. But otherwise, it was straightforward. Yeah. Oh. The funny thing is, I still did that in a minute and 30 seconds, even though I spent like 10 seconds debugging. So that was pretty good. Q3, longest contiguous or continuous subarray with absolute difference less than or equal to limit. I spent a little bit longer on this problem. Yeah, a little bit on the slow side, to be honest. But yeah, longest contiguous subarray with absolute diff less than or equal to limit. Yeah, I think I was just want to be careful because so what I was doing in the beginning was just pulling out my my quote unquote mono Q code or whatever, and that's basically the entire problem. I knew how to do this immediately, but I just wanted to make sure that my coding was right. So I'm still if you're a viewer of this channel, I'm still a little bit rusty with the mono Q or max Q or min Q implementations. But especially if I want to do it correctly, I didn't want to risk doing it off by one. Though if you saw the way I did it, this is actually pretty clean. Well, I mean, you could abstract them into different data structures, but in terms of not making off by ones and stuff like this. That was pretty good. But yeah, you just keep a max queue and a min queue, and then keep track for it all when you and then you do a sliding window. You move to the right. Is the biggest and the smallest still within the window? If so, then pop off and so forth. And that's what I mean, I'm a little hand wavy, but basically, if you input a number, or when you process a number on the right side, you check to see if the max q minus the min q is still within k, or the limit. And if it's not the limit anymore, then you have to start popping elements until it is within that limit. And that's pretty much it. Um, and I did some additional checking because I was like, oh, because there is a no subway satisfied the given condition, return 0, but every input has at least one element. That's why I paused a little bit just to make sure, because I've been sloppy with edge cases, so I just want to make sure on this one. But yeah, overall, that's pretty much it. And if you're having trouble understanding this part, just yeah, read up on mono queue, max queue, or min queue, and yeah, and not the priority version. So you could do it with priority queues as well if you really wanted to, and that would have been just fine. Especially because I thought about that, but I was like, just do it right. I didn't want to risk it. Cool. Last one, find the kth smallest sum of a matrix with sorted rows. So this one, my biggest issue, I don't know why I missed. I think I just was focused on the n to the m part, and I just missed the 200 part, to be honest. So that was a little unfortunate as a result, because I spent, I don't know, at least 15 to 20 minutes trying to figure out a general case. I was, and you could go back to commentary to kind of look at what strategy I did if it was the hard problem. Because if this was the hard version, I would have, because I thought about like, okay, maybe I could try like, oh, for say 12, how many combinations are smaller there, and then do a binary search, and then do that with dynamic programming or something like that. And I was trying to think about also different ways of doing dynamic programming, but all of them, like the math didn't really work out. That's mostly because I just missed the 200 part. And I think I have to see where the timer is exactly. So in the comments, you'll probably, I'll probably talk about it a little bit more after watching it again. But when I saw the case go 200, I was like, oh, that's easy enough to brute force in a way. You have to still brute force it smartly, and that's what I did with a priority queue of basically, yeah. And I worried a little bit about the queue or the priority queue being way too big. So I did a little bit of hack that I couldn't really prove, which is that well, I keep track of the biggest number that's in a queue, and we only insert a number that's bigger than the biggest number in a queue if our queue length is less than 40,000, which is an arbitrary number. I got that by 200 square. I don't know if that's a foolproof number, to be honest, and I don't know how to prove. I mean, I have to sit back to think about how, like this, my idea was that there's some pigeonhole principle type thing, but I'm not sure that that's actually true, to be frank. That was my gut logic. So yeah, so that's overall. I mean, I didn't get any wrong answers, so that was a clean contest. But I just spent too long misreading the problem. I think my ranking would be a little bit lower when I factored in the Chinese servers. Let's kind of see if I can take a peek to see that. And if you don't know, there's a trick where you just change the URL and it'll show you the Chinese rankings. Yeah, and people are very fast. Oh, but so I'm at 38, so that, or 38 minutes, so I added 20 people, so I'm like at 110 or so. Not bad considering I spent 25 minutes trying to solve a really possibly impossibly hard question. I don't know how hard it actually. Oh, this. So Chinese servers are, or some Chinese server numbers are here. I don't know what rank I'm in, but yeah. So overall, okay. Thanks for watching. Hit the like button, hit the subscribe button. Let me know how you did, and hope you had a good contest too. And I'll see y'all next week or whenever. Bye bye.